Hey, good evening. My name is Ivan Ross M. Reyes, and tonight I will be presenting to you the construction process of the function block diagram for the stamping circuit sequence, and I will also be showing to you the construction process of the logic module in this function block diagram. So, without further ado, I will be proceeding um, to the program along with my face cam so that I can be able to explain to you after the construction process on how the circuit is made and how it works. So let's proceed. So as you can see, I will be locating myself at the top right corner so that I will not be obstructing the view during the process. So before we start, um, we have here our logic module in which we are also going to be wiring later. And here we have our cylinders, our double acting cylinders, our 5-way valve, 5 over n-way valves, compressed air supply, and here is our given sequence, which is A plus B plus, A minus C plus, C minus and B minus, our voltage sources, 24 volts and 0 volts, a start button, a magnetic proximity switch, the logic module, which I just showed you, our solenoids A, B, and C, which corresponds to the solenoids located near the valves, and basically that's it. So I will now be constructing it, and I will be speeding up this process in order to save time. So let's proceed quickly. So we are going to connect these here. All right, so now that we've finished the circuit, let us proceed with the logic module. So now we have our completed logic module. I'm sorry. Well, we do have our completed logic module here, but I was saying we do have our completed function block diagram here. So as you can see, excuse me for a moment. Somebody is calling me. All right, I'm back. I was just called by my parents. So now, if we can see here, here is our completed function block diagram. And now if we run this module here, we should be able to get the sequence that we wanted. So there we have it. We have gotten the sequence of this function block diagram over here. So now, um, what happened? Basically, what happened, right? So, if we simulate this circuit, cylinder A must first extend, then followed by the extension of cylinder B. And then it should be followed by the retraction of A, followed by cylinder C's extension, and then followed by its retraction, and then lastly the retraction of cylinder B. So basically, A plus is the extension of A, B plus is the extension of B, A minus is the retraction of A, C plus C minus, this is its extension and retraction, and lastly B minus is the retraction of cylinder B. So the plus sign represents the extension process, while the negative sign represents the retraction process. So again, we have here the magnetic proximity switch, a push button, our voltage sources, 24 volts, 0 volts, our logic module, solenoids A, solenoid B, solenoid C, which corresponds to the solenoids of the 5/n-way valves in our pistons. So now, if we start simulating that, just what we did a while ago, the sequence mentioned prior, must be achieved. So that means S1, S3, and S5 will be triggered before I push the start button, which is true. So S1, S3, and S5 are triggered. See? So before I push the start button, it will trigger latching condition when A plus occurs. So when A plus occurs, F1 will be activated and therefore is closed. And due to that, it will extend cylinder A. And that when we activate it, the following process would be the extension of cylinder B. So the same logic applies to the diagram presented here, so that we are able to get the sequence here, which is A plus B plus, A minus C plus C minus B minus. So there we go. Let's just stop the simulation to prevent overclocking. So this is the finished function block diagram based on the PLC ladder diagram in my previous video that I've shown you. So I3 represents S1 since it is connected, I4 to S2, I5 to S3, I6 to S4, so on and so forth. And with this process in mind, or with this in mind, the logic presented here in mind, we should be able to, we did get the required sequence that was given to me for this completion module. So now let's proceed to the logic module, and this is just how it's supposed to look like when the diagram is functioning well, functioning completely. So lastly, let us just show you this output here. Alright, so before we end, let me just open up my other file that shows the PLC ladder diagram, just so we can show the comparison between the two outputs, and it's just to show you that both outputs yield the same. Both outputs provide the same sequence. So let me just open the file real quick. Okay, so now that we have opened the ladder diagram, the relay ladder diagram now, so this is the same sequence here. So if we simulate this one, we should be able to get the same output, just a bit quicker. And now if we go here and simulate this, we can clearly see that we have achieved the desired output. So that is the simulation, and thank you for watching.